welcome to our Monday meeting. Shall we start with company update?
Uh, Nothing particular. Shipped a bunch more tiny boxes. We finally have them in stock. The limiting factor was the CPUs. We got a whole lot more of them last week. Uh, more of the project for comma. Mostly that.
Great. Okay. So next is release. So let's do a release this week or after this meeting. I don't know. So I think the big thing we want to include in release is Onyx. So you don't need to import from Extra to use Onyx. So that's pretty nice. I think we can do a release maybe just after this meeting. I said I want to include some fix for Almost new model, but we can do that after. We can do a minor release once that is figured out. Alma hasn't released that model anyway.
The other thing I want to make sure about the release, I want to check the size of the wheel file. Like it should be around like a megabyte, because the last one went up to 10 megs. Yeah.
Last time includes all the include AM stuff.
Yeah. So I think we fixed that. We never did a release after. All right, cool. So who's handling this?
Yeah, I'll tag today.
Great.
You also just post somewhere for the release size.
Yeah.
Cool. Yeah, we shouldn't have anything else pending. Yeah, let's just do one release and we can do a subsequent one. There are like some other Onyx toolings I want to include. We can discuss later. Should this be 0.11?
That's right. Yeah, we include Onyx.
Great. One step ahead of comma. I think they are releasing 0.10.
I think we'll get to 1.0 first, maybe.
Great. Okay. So let's release. Let's move on to Rangify.
Yeah, so progress is slow, but it's there. I'm hoping this week to merge it and have it training Beautiful MNest. So first, for anyone, an update on what Rangerfi is. So Rangerfi replaces like 4 different things right now. So we have the grouper, which determines where kernels are split. This is what's currently there. We have kernelize, which actually does that splitting. We have the shape tracker, which builds these view UOPs. And we have the lowerer, which is what currently adds ranges to stuff. And Rangerfi is going to replace all 4 of those things with hopefully a much better version. So right now we have this separate logic called the grouper that makes decisions beforehand about which tensors are going to be realized. But this is not that easy, and it relies on a bunch of heuristics, which are not always true, and I think are actually causing some major issues. I think that's what's causing like these long strings of contiguouses. Like we do that thing, and it like has all the kernels, and it's because the current grouper is always making the decision to redo element-wise operations. And you kind of need this to lower kernel counts, but this should not be the right. You shouldn't say arbitrarily redo element-wise operations. You have to have a cost function here. So what Rangerfi does is, it also replaces all of the logic for view left and view right. So we have a big thing. I forget what it's in, but it's in CodeGen. There's a big thing in CodeGen. Where did I put this? Did I put in UOP? View left and view right. So what view left and view right do is they push these. Oh, it's in Swizzler, CodeGen opt. It also replaces kernel.py. It replaces really the entire opt folder, but I don't have that stuff yet. But yeah, so what view left and view right do is they push views. So instead of pushing views, we move indices through the graph. So Rangify is just basically saying where all the loops should be. And by determining where all the loops should be, you're also determining what should have a tensor, right? Because anytime you have a store, the store ends loops. Well, no, that's not always true. You can have a store to just one that doesn't end loops, but stores usually end loops, and like you can think of the end of a kernel, you have a store to globals, ends loops. Yeah, so it's a huge refactor. I hope to get it merged by the end of the week, not by deleting the other stuff. I'm gonna make an environment variable flag. You run it with rangify equals 1, and then you can start
Yeah, I
playing
think
with it.
that makes sense. Otherwise, we also need other optimization.
Yeah. So the main thing that I'm not going to get done this week is I hope everything's correct in Rangify, and I want to get all of the functionality tests working. But I'm not going to get tensor cores or optimizations. These are hard. Not that hard, but these require it's kind of a separate project. We could be doing a lot of this stuff now. So currently we do run kernel.py before the lowerer, which adds the ranges right now. But we have to move to something that looks like kernel.py after the lowerer. This is advantageous for a whole bunch of reasons too, because I think we can make beam search a lot faster. Right now, we are basically redoing we're at the kernel.py level when you redo beam search, but you shouldn't have to. You should just be able to make a quick change and re-render it. So that's Rangify. What I've been working on for almost 2 months now. But it does work, and it almost trains MNIST. Actually, it does train MNIST, it's just slow.
Oh, okay.
Yeah, I broke the yeah, it's correct, but I broke the indexing. The fast indexing, and if you don't do fast indexing, it's really, really slow.
Is it around Llama?
I should. I'll try today.
Okay. Anyway, okay, great. It should also replace the current fuse logic.
Yeah,
the one
So the
of
current
fuse.
So the current fuse logic, I mean, there shouldn't be, there's no reason for that anymore. There's no reason right now for like what we call fuse there. That would all be automatic. If you want to redo compute, we'll have to have some new way to specify that. But I think that's a lot more rare.
Yeah.
Like Rangify should just flash attention is an obvious pattern. Rangify should just absolutely generate flash attention. And then if you want what we currently have, contiguous still works. You can also do partial contiguous. You can also say contiguous, you can give it an arg, and those args are axes, and the axes are, they will only contiguous on those axes.
I think those I and other people can experiment once that is merged.
Cool. Hopefully this week.
Yeah. I think one thing to add is we both agree that the render stuff and the codegen is pretty robust. I think so far it rendered pretty much correctly everything.
Oh yeah, the render and the linearizer are great.
Yeah, those seven back-to-back loops and like some splits and merge thing seems to be pretty correct.
Yeah, I mean this is the third linearizer I wrote, and this one I think is good.
Great.
Yeah, it's fast too, so we're happy with that.
Okay. Yeah, looking forward to that. So moving on, next is Llama. So I don't have a new picture for the whiteboard. It's the same as last week. I think we are at 7B model parallel. For that one, basically I'm waiting for eval. That's one thing. I really want to see if the eval is correct. Then there are compiler errors both on LLVM and HIP that I hope would disappear after we upgrade the compiler versions. We will follow up on that. My hope is we can like around 7B was split the model on 8 GPUs.
Oh, as far as I can tell, both MI300 boxes have LLVM20 already.
Okay. Is that the version that's being used?
Well, it's the whatever latest LLVM version is.
Okay. Anyway, yeah, I'll confirm this and see if it's like our bug or whatever bug it is. It's just weird. And I don't have updates on gradient accumulation. I still don't know what's happening. But I started to look into what's. Oh, sorry. What's paragraph?
Is there an update on 8B?
Oh, you mean their PR?
Yes.
As I check, not really. So I mean, even if they merge that PR, they haven't released a new data set. They say they will.
What is merged?
So it's okay. Then it's either I think it's either we follow their setup to generate the data, or we wait until they update.
Oh, the data was uploaded an hour ago.
Okay, great. Okay, then we can try that and run an AB model. Good. So what's part?
I don't think we can fit this on the 350 boxes.
Oh, because the context too big.
No. Like on the drive in the 350 box.
Oh, we don't have.
Yeah, I can order. I'll order more drives. We're gonna put in. I tested the new ASRock cards. They're good. I just didn't get around to ordering them, but I'll order. Send me the model number of those drives. I'll order 16 of them.
Okay.
And we'll put. Yeah,
How big?
we'll put them in the computers.
How big is the data set?
I'm assuming it's same size as last one.
Yeah, we can delete the one for bird. We don't really need the bird one if we are low on storage.
I can check, yeah.
Yeah, so because that is 1 terabyte, right? And this new one is like 1.1 presumably.
Yeah.
Okay. Looking into smaller D type, and I just realized for the AMD renderer, we still have a bunch of crabs for E416. And when I try to remove that, some other hit compiler issue happened. So I will also look into what's happening there. I think we just want to support BFlow16 would definitely support FP8. I would imagine if it's trainable, it's just a nice to have option to save like even more memory. Because we can just use that for weight. Yeah,
I just
so-
open a PR to fix the F16. You can check it out later.
Okay, great. Yeah, so I saw a bunch of your fix what George mentioned as well.
Yeah.
George, do you want to quickly check the C style one and the cast one? Both you requested before.
Sure.
Yeah. So hopefully this week we will have Llama eval and run the 70B maybe smaller context windows than some AB going on. Hopefully we can start to like train those as well. And that's
Oh,
not,
sweet! You fixed the cast. Nice.
yeah, just review those and we can move on to like more stuff. And yeah, we will discuss other MLPerf stuff in other bounties. And that's all I have for Llama. So with that we can move to this.
I realized that the problem with Wiz is that we can't fetch the entire llama trace to the browser. When you forward with SSH, it's extremely slow over the internet, and it's just the 100K event, so it's out of memories. I have it here
Wait,
already.
how big is the trace?
It's like 100,000 events.
Okay, that sounds like a very small number.
Still, like it takes, I don't know, a couple seconds. But
I
it's not
don't
really-
generally like this trend of saying, okay, like the browser's slow, so we're going to offload it to the server. Like, why is the browser slow? The browser's running on a fast computer. JavaScript's faster than Python.
Out of memories. So basically, like
Okay, so you're telling me that my computer with 48 gigs of RAM can't handle 100,000 things?
the browser limits how much RAM a tab can use.
How much?
I think it's different per browser. Some things work better on Firefox. On Chrome, it's a couple gigabytes.
Okay, so I have 100,000. How much kilobytes do I have per event?
In total, the Llama trace was around 2 gigs.
2 gigs. So you're telling me it's 2E9 divided by. Okay, that seems plausible. And that's too big for a browser?
I think so. When I tested on Brave, it crashed. Another problem is that when I forward the SSH
Huh.
from my 300X machine, I have to enable compression. Like the default path is too slow for my download. I'm in Europe, so maybe like faster when you're in
You
the
have to
office, but
enable what kind of compression?
so there's like this flag for SSH forward porting. I don't know it, but you can enable compression when you're forwarding the port, and it will.
Okay, so how is this lower if you pre-process stuff on the server?
You would basically calculate the layout on the server and get like a higher level layout. So not send like the full 100K trace events, but send like the shape of the timeline in unit vectors, and then the browser just rescales those 2 pixels and draws it on the screen. It would like at the zoomed out level when you're looking at a couple minutes
But
trace,
so
you don't see like the tiny little things.
when you zoom in, does it have to make a new request from the server?
Yes.
Yeah, I don't like that.
How big is this llama?
Couple gigs.
I mean, which llama you are talking about?
It's the, I think, let's see, 70B.
Yeah, so even if this barely fits when it goes to 4 or 5B, there's like it at least it's like double the size again.
I mean, yeah, it adds a lot of complexity if you have to start like zooming in
So
and re-requesting regions.
yeah, I think maybe instead of doing the like I don't know how complicated it is, but it sounds complicated. Even if we really do like pass all the hundreds of thousands of events to a browser, it's just hard to believe humans would like read them one by one. It's like there's no way. So maybe start by like dropping stuff so that we at
Yeah,
least can and see what's there now.
what are the 100,000? What can we just drop?
Kernels that you run. Each of the events represent a kernel. Or it could represent, I don't know, a buffer allocation, deallocation if it's a memory.
Yeah, so I think a better design for this might be just started from the user's point of view. Say, for example, I'm training a model. What do I want to see? Maybe I want to see the buffer allocation. I want to see how memory is used. I want to see like certain time stuff. Maybe I care less about like individual kernels or like rewrites. Is there a way for me to either turn that off or I don't know, not showing that by default or something?
Okay, well, I
Because
definitely want to show. I definitely want to show everything by default.
I don't want
But
to see everything by default. When you
all
train
right,
a
how
very
bad is?
big model, the use case is very different from like looking to single rewrite, I think.
I'm still not quite understanding why 100,000 is too many. That would be 20 kilobytes each. So the per tab memory limit is 4 gigs in Chrome. I mean, the thing that I'd really love to see be the solution here is like, each one of these things is 10x larger than it should be.
I mean, JSON.dumps is slow. Yeah. Protobufs.
Yeah.
Like,
Yeah,
look
can
at
we?
it. There's
Well,
pip install. You have to pip install. Like the only thing that's available as serialization is JSON. JSON is layout. Yeah, those strings are too much. The same thing would be much smaller in a.
yeah, I mean, we might want some. So you can make some byte pack format. Like, how many things do you have per thing?
The pickle is much smaller than the actual JSON.
How much small?
A couple megs.
Wait, how is a pickle of 100,000 things a couple megs? This seems wrong the other way.
A couple hundred megs. Sorry.
A couple hundred megs. Yeah, I mean, what I would do here is, well, first we should figure out a number like that we want to target, right? Because fundamentally it's just a target. Like it's never going to work for 10 million. And then, yeah, having some command line flags to turn things off is fine, but not on. Because off people will figure out, on they'll never figure out. But yeah, I think that might be the idea. So how much stuff do you have to store per event?
Timestamp. Key. And time.
Okay, this sounds like 10 bytes.
Yeah, it's small. Part of it is
Yeah,
just
so
JSON.
100,000 of these things should be 10 bytes each. That's a megabyte. Ditch pickle, ditch JSON. These things are the problem. Just store the bytes.
Yeah.
Think about it. JSON's printing these numbers.
Putting strings everywhere.
Yeah, and it's slow. Just have Python put the bytes. But okay. The other question here is, yeah, and then I guess Chen Yu's suggestion, if it's still not enough when we get to 405b, have some environment variable which can turn off certain trace events, but off, not on.
I see.
But yeah, the solution here is definitely not to move things to the server. I think the solution here is, because this is complexity that nobody can maintain. The solution here is to say, wait, 100,000. Okay, even if they're 100 bytes each, that's 10 megs. Right? Like to ask, like this just doesn't add up. These files shouldn't be that big. I guess that's, yeah, the metric here is bytes per event.
What constitutes an event?
Kernel run?
Like if I run the kernel, how many events roughly that is?
One event per kernel, one range event.
Oh, so
That's fine,
each
64,
kernel is
and-
one event,
Yeah.
and all the rewriting information of that kernel is part of that event.
No, rewrites are separate events in the tiny device.
Oh, okay.
I mean, rewrites are also pretty rare compared to kernel runs, anyway.
Yeah, they're cached.
Oh, okay. Cool. Sounds good.
But yeah, the main thing I would focus on here is just reducing the size of each event.
Another use case I'm interested for this is I was trying to use this to debug to work on the MLE, the OLMOE model because we have LabMT. And my use case was I was trying to use this to run the thing and see if I can find what's slow. And it turned out to be not very useful compared to if I just git equals to 2 and like debug, like and print debug equals to 2 and read the kernels. So not entirely sure like what's the solution here, but that's the use case I think people will want to use. Basically run OLMOE or run stable diffusion or any of the inference task and they want to use this to understand where the bottleneck is and how potentially they can make faster. For example, we discussed the idea about like kernels that is hitting either the compute bound or memory bound or cache bound, things like that, to understand what's the limiting factor and stuff like that. I think currently we don't have enough tooling to show those.
What was your experience when you opened Viz?
So first, OLMOE spent a lot of time loading and big has the weights. So my Viz timeline is dominated by that part. It's very hard to find the actual steps that runs the OLMOE steps. One. Then it's just not that easy to figure out after I figure out which chunk of the timeline is it's the 10 steps to figure out what's the bottleneck. You should be able to try that and just run the OLMOE. Imagine your task is to make it fast, and this is the profiling tools that you have. Does that help you? I think it's a good practice. I don't have concrete suggestion here. It's just I try to use that for improving the inference speed. It turns out not very helpful.
So, I mean, how much of the problem is that you need the memory planner in Viz?
So OLMOE, I don't think it's a memory issue. It's more of are some of the kernel too slow for no reason? Because similar to Llama, we already hit the limit. And I think one interesting thing I observed by reading debug equals to 2 is the same kernel sometimes can hit the limit and sometimes cannot. I don't know if it's data dependent, depends on which expert is being picked. If so, that would be interesting. But that's only if I read the debug equals to 2 per kernel numbers and compare that to the theoretical limits that I know.
I wouldn't think it's data dependent, but it could be dependent on like whether something's hot in the cache or not.
Yeah, or that. So because if you think about it, when it beams, maybe the patterns matters or something. But anyway, so I surely hope this experience can also like whatever I learned by reading the debugger 2 or like per kernel information can be like shown or it's easier to observe the viz as well.
Yeah, I can add, there is a feature in Perfetta where you can actually select any range with your mouse and it will sort all the kernels and all the events inside this range. So you can actually see like the timings, the average time each kernel takes, like the total time, like the average time multiplied by the count each kernel run.
Mhm.
So yeah, that's pretty useful for debugging this. Maybe we need such kind of table in Viz as well. And it's not like only visual on the like on the timeline, but you also have a table with timings. Like we can also add like the average time, the minimum and maximum time for each kernel.
Okay.
Yeah. So
I mean, yeah, I don't know what would be best here, but this is the use case that I imagine like other people will use a lot as well. Just having a tools to understand where the bottleneck is.
I'll look more into that. I think the Perfetto one, the table is kind of raw, but maybe we can find another to make another one.
Yeah, I think just try to run OLMOE with maybe JIT being equals to 2 and like this and see what you are seeing and see if that's helpful.
Cool. Yeah, it gets into the performance counter stuff with the bottlenecks. Like you should be able to see it very clearly.
Okay.
Having kernels set up.
Sounds good. Okay, let's move on to drivers.
I want to say one more thing about this. If you do want to change the format to something, if you want to change the format to something custom, write a spec of what you want to change the format to, and I'll look it over. And then before we code this, we should have an estimate. Like we are designing the new viz to be able to handle, I think 1 million events is reasonable.
Yeah, I think,
Yeah, so put a spec together about your data format that's going to store 1 million events in some 100 megs.
I think that's 100 megs. I guess.
I think it's 100 megs. I can't imagine an event being more than 100 bytes.
We'll see. Yeah.
Cool.
Okay, driver.
yeah. So yeah, I've seen your complaints about NV driver. I'll look in details this week. So basically, I mean, there is something that still inserts the NVIDIA driver. So in these machines, and I'm not sure exactly what's doing that.
If that's the issue, you just blacklist it on the machines. You add it to like mod probe and blacklist it.
Yeah, I'll try that. So yeah, so for AQL stuff, I have a draft PR. So AQL. So with AQL, so basically that's like the AQL queue, and we can execute the PM4 packets in the AQL. So that's like the first approach, and the second approach, I think, is that we can just execute AQL from PM4 queues. So, like the difference is like what the base type of compute queue. So the second one, I mean, where we have like PM4 queue and execute pocket 3 AQL pocket. So it should be better because we can use bint, but so there is no documentation for this bucket, and yeah, we then need to reverse it, or maybe we can ask AMD for the semantics for this bucket. But it should be better for us because
AMD has never been useful at this.
yeah, but yeah, they've never used them like in tests. I don't know if it's even like implemented on like modern machines. Yeah, but there is
Yeah,
one
so
in some headers.
yeah, I think it's 99. PM4 99 runs
Yeah.
AQL. Why do I know that? I mean, the advantage to actually like making the base type of the queue be AQL is that it just copies what the existing driver is sending. I don't know. I would briefly. I understand why it's easier if we can leave the base type as PM4. I would maybe briefly try it, but I think we're just going to have to make the base type be AQL so we can make it match AMD's implementation.
Yeah, but yeah, I've done that, but actually there is some problem with AMD LVM because like the kernel is not compatible. I think maybe I need to. Okay, I'll look into
What?
that. But there is. I mean, it can find the AQL header, so it can't execute.
Oh,
this
it's not
kernel.
generating the AQL header. Yeah.
Yeah.
I don't know. I don't know where those come from, but I'm sure we can figure that out. I'm sure that's some flag somewhere.
Yeah. But basically, like with AQLQ, we just steal all the signals and all the signals are in PM4, and only kernel execution is in AQL.
Yeah,
So
that should
because
be fine.
yeah, we
If the
can't
base
exactly
type is
yeah, because like HSA signals are quite annoying and quite limited what they can handle, so it's will be really hard to match to use them like in HCQ. So yeah, that's why we stick to PM4.
I'm pretty sure that path is used in AMD's stuff too. I'm pretty sure the path where you call into PM4 from an AQL queue is used in their tests.
Oh, it's used even in their like runtime.
Oh, great. Yeah. Let's do it this way. I feel much better about that, and we could keep all the signals in PM4.
Okay, yeah. Yeah, I think I'm gonna merge it, and maybe after that I can clean up all the. Yeah, I think I'll merge it under flag, and maybe after that we can clean up all the XCC stuff from PM4 we have right now. And just leave in AQL. Yeah. So
Yeah, I'm okay
for
with only supporting. Yeah, I'm okay with only supporting AQL for the MIs.
Yeah. Okay. So yeah, and timings actually look good already. I need to fix some things, but yeah.
Sweet.
So yeah, so 4 a.m. MI400. There's some progress, but I spent a lot of time. So figuring out some. I mean, actually, because of these GPU support XGMI, they have different aperture mappings, and basically, yeah, like it was quite strange to debug because it worked on one GPU, not on another, because like the window is floating based on which PID each GPU is. So yeah, but I also fixed that, and it's should be pretty close to merging it. I already merged some like parts from it. So yeah.
Cool.
Yeah. So yeah, and also maybe AQL support for AM as well. I'll do this week. So not much there, it's just several flags.
Yeah, I'm happy the kernel time is going to be fast. This will just be free speed up.
Yeah, I mean timing looks good. I don't know why, but we're still faster than heap. Like I don't know what's the exact reason like for this. But yeah, timings look consistent right now. I mean the launch time of small kernels.
That's good. Okay. Next is anything for Cloud? I think there are several open PR from UUVN as well.
Yes. So I tested the thing. Does the bounty include beaming the model?
Which bounty?
The host time within the multi-host one.
It should, right? Right? I don't know. George?
Let me read the text of the bounty.
This is training. Well, we dropped resonance. So training BERT on 3 GPUs across 2 machines, getting 80% of the same machine speed.
Yeah, of course you have to do that with Beam.
Okay. So it doesn't work with Beam because we don't propagate runtime errors from Cloud Node. UVN says he's trying to reproduce it. So that's fine.
Yeah, I mean, it has to be like this. It has to be our best speed, right? You can't say, "Oh, it's the unbeamed
Yeah.
speed."
Because
I
only
can look
when
into-
you beam, you would see like other things, because now the ratio between kernel launch time and other stuff versus kernel runtime can be much closer.
Yeah.
Yeah.
Exactly.
Okay. Nimogen, you were saying something?
Yeah, actually, I want to say that I think I fixed the propagation error from Cloud because I needed these for tests. But yeah, okay, I think UN will figure it out.
I think Nimogen said he also wants the proper
No,
propagation.
I mean, I've
Or
done
you already-
like the propagation from the I know strange it doesn't work for Beam.
Yeah, I don't know. I was testing it and it still failed on the remote.
Okay. Anyway, so that's the definition of lab bounty. Anything else?
I think that's mostly all.
Okay. Symbolic.
Yeah, hi. So most of what I've been working on is like last week, you talked about the shape tracker tests and making sure that those simplify well. So I've just been, I mean, I guess basically what you want is to index uops, like the function in the lower, that generates nice expressions without having simplified the shape tracker. So I'm just trying to see what rules I'm missing for some of the symbolic simplification so that gets done. So that symbolic can find those simplifications.
Yeah, so in
George,
general,
that's-
I think it's good to make the simplification rules more complete, but also I heard shape checker is going to be removed soon. So
No, but I
Well,
requested this. So the task is not to improve shape tracker. The task is to make sure that, so when we remove shape tracker, you're basically going to get the same patterns, and symbolic's going to have to do them because we're not going to have merge views anymore. So the
yes.
project,
that's what I'm.
and that's the project here. Yeah, I think you captured it correctly.
Yeah. So I mean, what I'm doing now is just have one shape tracker that's simplified and the other one that's not. And then when you generate the indexing from the unsimplified one, you want to make sure that it simplifies with symbolic.
Yeah, this is right, and
Yeah,
it's good to
and-
do this before shape tracker goes away, so that we've
Yeah, so
Yeah.
my experience doing the first version of this, when we initially remove symbolic and use the rewriting rules for symbolic, is to make sure you have a script that generates the diff between the two you just mentioned, the width and the old method with shape checker math, and the new method with only symbolic rules, and have a metrics to track like what having an easier way to see what's left not done help you to figure out what rule is missing a lot easier.
Yeah.
Remember there was some like
I mean, I
symbolic diff.
think the hardest part is going to be the valids, actually. But I think there's not that much missing to get the sort of diffs or like division to get that to simplify completely.
So when
Like
you
that's
get here
pretty
next
close.
week, I think that's going to be your in-person project. We want to figure out how to basically mix index and valid. So like what invalid really is imagine like a where that has like a poison value or an invalid value inside the indexing. And I think this will help us like with the simplification of indexing and valid as well. But yeah, we'll work this out when you get to the office.
Yeah, I mean, there's some simplifications you can only make if the valid is true or false.
Yeah. But no, I want to like
Yeah.
combine the indexing, the valid. I don't know. We'll explain it when you get here. But I think
Yeah.
otherwise this is a good project, and yeah, I definitely agree with Chinyu's suggestion of making an automated thing for this.
Yeah.
For generating shape trackers and checking. Cool.
I mean, yeah, I'm just using the fuzz shape tracking math. I mean, I don't have a metric set up for it, but it's just generating like hundreds of expressions, and I can see if they're equal or not.
That sounds
Yeah.
good. Cool. Okay. Next, there's a numpy importing dropout. So I won't worry too much about this for now. Let's make a release first. We can have a cleanup release after. I don't see the point of blocking this for release. And yeah, definitely interested in those shape not being cached properly, and basically at this point you are the Onyx expert, so you know much more about what's not done, and we definitely want to support those. The ones I can think of is the symbolic shape and the if up to support the comma's new big model. So I think you are on the good progress now. So let's make a release, and we will have a follow-up once we fix more issue. And speaking of Onyx specifically, so I when I was in San Diego, I was promoting Tinygrad to Kama's new people to have them try to use Tinygrad more, and I also asked them to open issue. So the ones I tag you into is one of the issue that they start to use Onyx, then see there's a difference between Tinygrad's implementation and Onyx runtime in terms of output. So I think having a workflow or a tools that can show where Tinygrad is generating different output would be very useful. Now we want more people to use our Onyx. I can probably sponsor a bounty if you get the tools in, and we can use that tools to fix that specific issue that running an Onyx model on CUDA produce different results than GPU. I think that would be a nice tool and workflow to have. Yep. Otherwise, good job on Onyx. yeah, I'll post more in the Onyx channel after the meeting. With that said, we can move on to other bounties. I see Hoof, you want to say something about training Stable Diffusion?
Hey, sure. So I mean, I wrote up most of the recent progress in one of the other Discord channels. I'm setting up on TinyAMD1 to do training there, scanning batch sizes right now to see what will fit in memory. Seems like at least 248, which is it's going to be a lot faster. This is really good. So once I'm done setting this up, I'd expect to be able to train within, less than half a day, hopefully, including eval. Fingers crossed if everything speeds up with Beam, etc. So yeah, I'll post updates in that channel.
Cool.
But yeah, the main issue was it's basically the same issue we discussed a couple weeks ago, which is I think the learning rate was really mismatched with the batch size, and we didn't want to do gradient accumulation because that's a little bit different than the official MLPerf reference. So we're trying not to do gradient accumulation. So yeah.
Okay. I mean, the only thing I would say is if you expect to run something for extended period of time, just post in the Tinybox access channel so we can sync, because we only have like 2 MI300X machine. It's fine if you have calculated everything and just need some time to run, but just post there for estimated time so everyone else knows like not to break your job first, then know when that will be free.
For sure, I'll do that. Right now, I'm just running a couple minutes at a time, but I'll post that when I have it ready.
Sounds good. What else? B1TG, you want to add something?
The reduce access PR is still review.
Yes. So I can look that over again. There were a few things commented out that I'm not totally sure they had to be. I merged your cast and your other thing. Let's see. I don't know. I'll look this over more today. I think it's probably good to merge. If all the tests pass, it's probably not wrong. Cool. Yeah, I'll read Mr. Master. And if the test pass, I will merge that, and the bounty's yours.
I also unlock OLMOE bounty because I want like more people to try that, and also I'm poaching my friend, so I want something for them to do. We need more bounties apparently.
Great.
Yeah, I think that, and I think some of the old bounties maybe is either considered done or we probably need to do something. There are some of the really old ones.
I hope with we already sort of have it with like the Rangeify language. I have that one where I like make the kernel fast. We need to figure out how to get bounties for people to just do performance. We need to figure out some system to do this, but
Yes, I think for now we are in a limbo because a lot of these performance bounty will directly or indirectly solved by Rangeify. So once we have it, maybe we can like revisit these.
sounds good.
Yeah, so I think having people to do performance, and we should be able to provide a set of tools that help them improve. That should be the default tools we recommend people to improve the performance on stuff. See, Harold, do you like the TinyGrad? Are you a happy TinyGrad user?
Yeah, I've had no issues recently. I guess AMD GPU is the only thing we're working on now.
And we will fix
Um,
your big model.
You mean fix the performance?
We will first get it to run, then we will think about performance.
Oh, I see. Yeah, it doesn't run on master yet. Yeah.
Yeah, let's start from there.
Yeah, because if not, we can look for different architectures that already compile well. But if you guys want to fix it anyway, then that's fine.
So we definitely want to fix it anyway, because that's the point. We don't want you as a researcher to pick architecture just because the compiler supports it or not.
Right.
So
yeah. Okay. Yeah, that's fine then. We'll wait until Tiny gets fast.
Great. Okay. Know what happened to a whisper bounty? If there's an update, we can test.
Yeah, I'm waiting for the Whisper bounty. Post a link and say copy and paste the MP3 file of the last TinyGrad talk in there, and it just works. That's great. Yeah, no, with the Whisper, just tell me when you're ready to claim it. Give me a link. I'll test it a bit.
Okay, I think that's it for this meeting. Thank you, everyone. See you next week.
Thank you. Bye.